Hello, today we are talking about two words that can look kind of intimidating because they're kind of long, but it is called multiplicative comparisons. And at its heart, multiplicative comparisons is just comparing numbers, numbers specifically that are being multiplied. So today we're going to start off by just looking at the number 2. Okay, so 2, we can represent it with squares looking like this, right? We've got two squares, 1, 2, representing the number 2. Okay, since it is multiplication that we're going to be comparing, right? So multiplicative comparisons, we're going to start off with a multiplication sentence that I'm sure you've seen plenty of times, 5 times 2. Okay, if I wanted to model 5 times 2, I want to show what that looks like. So I started off with the number 2, but I want to show 5 times that amount. So it could look like this. If I did it like this, there's 1 times 2, there's 2 times 2, 3 times 2, 4 times 2, and 5 times 2. So now I've got models showing 5 times my starting number, which was 2. If I wanted to know how much that equals, like what's the total of that, I would just count the squares, right? So I could have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'd have 10 total squares. If I wrote that in my number sentence, it looks like that. So 10 equals 5 times 2, represented here as my starting point 2, and down here I did 5 times that amount. So if I want to write this as a multiplicative comparison, all that means is that I'm going to be writing it with words that match this number sentence. So if I have 10 equals 5 times 2, the multiplicative comparison looks like this. 10 is 5 times as much as 2. So 10 matches the first part of the sentence, right? Is matches the equal sign. So the equal sign means is. 5 is the next number. Then times means times as much as the next number, which is 2, which is my starting point, right? I started with a 2, and then I got 5 times that amount, and it turned into a 10. So that is how you write a multiplicative comparison. So it's a number sentence that matches the word sentence. Okay, here we've got an array with squares. Okay, if we look at this array, we can see it has 7 squares going across in this top row, right? So I've got a row of 7 here, a second row, a third row of 7, a fourth row of 7, and a fifth row of 7. So if I counted all those up, I would have 7 times 5, which is 35. I could count each one individually, like 1, 2, 3, 4, 5, all the way across. I'd still get 35, right? So if I wrote this as a number sentence, I see that I had 7 groups going across the top, and I had that 5 times. So I could write it like this. Here's my 35, my total, equals 5 times that original grouping of 7. And if I want to write that as a multiplicative comparison, it looks like this. 35 is 5 times as much as 7. Okay, now let's say, though, that I'm a person that doesn't like to look at the rows first. What if I like to look at the columns first? That's the part that goes up and down, right? Up and down this way. So I have columns that have 5 squares in them, right? 1, 2, 3, 4, 5. So how many groups of 5 do I see? Well, I've got the first column, the second, the third, the fourth, the fifth, the sixth, the seventh. So I have 7 groupings of 5. So if I wanted to write a number sentence that represents that, it looks like this. 35 is 7 times the grouping of 5, right? So there's 7 times that I see the number 5. So if I wrote that as a multiplicative comparison, it looks like this. 35 is 7 times as much as 5. Now, did it change anything? No, there are still 35 squares, no matter if I wanted to say 5 times 7 or 7 times 5, right? Doesn't matter if I'm looking at rows or columns, there are still 35 total squares there. So in math, there's a word for this that means that I can take my factors and I can swap places with them. I could put the first factor second and the second factor first, and it doesn't change the answer. And that is called the commutative property of multiplication. So that property just means that it doesn't matter if you switch the order. I can say 5 times 7, and I can say 7 times 5, and I'm still going to get 35. So today, when you go to make multiplicative comparisons, it does not matter to me if you look at the row first or if you look at the column first with arrays, or if you write one factor before the other. As long as your answer is the right answer, you've got it correct. So that's because of the commutative property of multiplication. It does not matter which order you write your factors in.